this. Okay, so we're recording. Okay, so natural numbers. Natural numbers, y'all, look like this. 1, 2, 3, 4. You know what the little dots mean, right? Continuing on, so on and so forth. Okay, now we have the set of whole numbers. This is what whole numbers look like, y'all. What's the only difference between the natural numbers and the whole numbers?
Zero.
The zero. That's the only thing that we did. Okay, so natural numbers, whole numbers. Hello, hello. Y'all, I have some booklets up here for y'all. You want to grab one? Okay, now the next thing we have are the integers. Hello, hello. I have some booklets up here for y'all. So they're pretty thick booklets, y'all. So you need to grab like the whole little chunk.
Are they just all loose?
But you know what? You're making this harder than it needs to be. There you go. Here's one. Hold on. I've got more paper for you. That's it. Okay, let me get one for you. There you go. Uh-huh. Okay, so guys, look, let's look at the integers. What do the integers now have? So look, remember, natural numbers, 1, 2, 3, 4, right? Whole numbers, 0, 1, 2, 3, 4. Look what we have here. 0, 1, 2, 3, right? Obviously 4 and so forth. What else do we have now? Negative numbers, right? You see how the sets are getting bigger? We're just adding extra stuff in there. Okay. Now, rational numbers. Integers. Sorry about my handwriting. Plus numbers that look like this. So what did I add now? Fractions, right? Decimals. Those decimals, y'all, can be decimals that stop, like negative 0.0137985. Decimals like 0.2391197 and go on and go on and go on forever. Things like that, right? That's what rational numbers are. Okay. So I have all my integers. I have negative 1, 2, 3, 4. I have 0, 1, 2, 3, 4. I have any number that I can write as a fraction where the top number and the bottom number are integers, like 1 over 2, 7 over 11, negative 9 over 17, right? All those decimals. Okay, now we have this other set over here, irrational numbers. Okay, have you ever seen a number that looks like that before? Right? Not too pretty. Okay. Y'all remember this from high school? Remember that number? Pi? Okay. Funky numbers that look like that, y'all. The square root of 17. Now, one thing I do want to clarify though, in my rational numbers, y'all, you know what number would be inside there? The square root of 25. Does anybody know what the square root of 25 is? 5. That's why that number is going to be there, because the square root of 25, we can actually do it, right? If I said, and you might say, well, how do I know the square root of 25 is 5? Well, because 5 times 5 gives me 25, right? But if I were to say what number times itself gives me 17, I would say, I don't know, because I know 4 times 4 gives me what? 16, right? It's kind of close to 17. And 5 times 5 gives me 25, but it can't be 4 because 4 times 4 would give me 16. I know it's not 5 because 5 times 5 gives me 25. Well, what number times itself gives me 17? I don't know, 4.1, 4.2, somewhere in there, right? But is it exact? No, it's going to be a bunch of little funky stuff, right? So we're going to have all those kind of decimals in there, right? That are going to keep going, and but it's not going to be a pretty number, okay? So these are my irrational numbers here, okay? Now, let's come back over here. Look what we have here, y'all. Here are my natural numbers. Here are my whole numbers, right? Here are my integers. Here are my irrational numbers, right? Square root of 20, negative square root of pi, right? Decimals that are not terminating, but they don't repeat, okay? Real numbers, y'all, we add those two sets together. Now, what I want us to do, y'all, the one thing about the TSI test, when you took it multiple choice, it was multiple choice, right? It's a multiple choice. Guys, what I try to do here is I try to pull the questions so that they're multiple choice, so you can kind of, again, get a similar experience. So look what the first problem says. Tell which set or sets the number belongs to. Negative 86. Okay, we want to know, is negative 86 a real number? Is it an irrational number and real? Is it a whole number and real? Is it an integer, a rational, and a real number? So guys, one thing I want to mention, every one of the numbers we're going to have, they're all going to be real numbers, okay? So if I look at my 4 choices, well, all 4 of them have real numbers on there, right? But now I got to figure out, okay, what kind of number is this? So negative 86, okay, I know it's real, but that doesn't really help me narrow down my choices, does it? Okay, now the next thing is it going to be irrational? Remember what we said irrational numbers look like, y'all? These are what irrational numbers look like. Kind of funky numbers, like the square root of 20, negative. Okay, so that's not an irrational number, right? Negative 86. Would you say it's a whole number? And if you're not certain, it's okay to come back and look. Look where whole numbers started, y'all. Where did we start at? We started at 0. Okay, well, it's negative, so it's not that. Would it be an integer? Yeah. And if it's an integer, isn't it also going to be what? A rational? And every one of them is always going to be what? A real number, right? So we're going to come back over here and we're going to say, you know what? My choice here, y'all, has to be D, right? So again, what I want to point out, y'all, is when you're doing these problems, the choice is not like, oh, this is the one. I know it's the one. If you notice, all of them had real numbers up there. I got to narrow it down, okay? Let's take a look at the next one. Square root of 20. Remember, they're all going to be real, okay? Square root of 20, is that a pretty number or a not so pretty number? Yeah, it's going to be irrational, right? So it's going to be irrational and real, right? Because it's not one of those nice numbers, right? Okay, let's take a look at 0. Okay, is 0 a real number? Yeah, they're all real numbers. Okay, again, that's just, I'm not trying to trick you, but I just want to make sure everybody understands. They're all going to be real numbers. Okay, is it a whole number? Yes. Yes. Okay, so look, now I have 2 choices. It's either B or A. Okay, is it an integer? Yes. Yeah, it is. And it's also what else? Rational number, right? So my choice here, y'all, is going to be A. Does this make sense on how we're going about this? Yeah, we're doing okay? Guys, at any point in time, if I say something and it doesn't make sense, tell me. I want to make sure that you guys are clear with this, okay? Okay, so let's take a look here. Look what we have. We have 0.8686. Those 86s, y'all, are continuing to repeat. Okay, so look, 86, 86, right? 86. Okay, so let's come back. Let's take a look at what we have up here in our notes. Okay, rational numbers are what else? Repeating decimals, right? So look, let's come back over here. And so this is going to be rational and what else? And real, right? Because every one of them is going to be real. Okay. Now, again, y'all, I want to make sure everybody's okay why it's not a natural number. Remember, that's a decimal, right? Natural numbers are 1, 2, 3, 4, right? They call them the counting numbers a lot of times. All right. Okay. So, guys, y'all remember this? Maybe you do, maybe you don't. Order of operations. Okay. So, order of operations. Did anybody ever learn order of operations like this? PEMDAS, right? Okay, a lot of us, y'all, learned order of operations like this, PEMDAS. Guys, this is the way I learned it too. There's some good things about it, there's some bad things about it. Number one says we're going to do everything inside parentheses. That's what the P stands for. Y'all, it also includes brackets or little squiggly braces on the side, okay? So I don't want you to think, well, it's only parentheses. Any kind of grouping symbol, whether it's a round parenthesis like these, whether they're square brackets, or whether they're those little squigglies, okay? What did the E stand for? Anybody remember? We're going to take care of anything that has an exponent, right? Anything that has a power. Okay, what did the M and the D stand for? Multiply and divide. Now, guys, this is the part I want you to look at. Look at number 3. Look at what number 3 says. Multiply or divide. Which one do I do first? I have to go in order from the left to the right. Okay, whatever comes first. If I see multiply first, I'm going to multiply. If I see divide first and then multiply, I'm going to divide first. I have to go in order from left to right. Same thing with the adding and subtracting. Whichever one comes first from left to right. Okay, so let's take a look here. We're going to do this in pieces, y'all. Number 1, do we have any parentheses in this problem? Yes, we do. Okay, so y'all, look what we have here. We have 2 minus 6. I want you to think of 2 as I have $2. If I'm subtracting, I want you to think as that means I owe you 6. If I had $2, but I owed you 6, and I gave you the $2 that I had, are we cool, or do I still owe you money? How much money would I owe you? Very good. Because I owe you 4, y'all, it's a negative 4. Squared, I'm just going to write the rest of it. Divided by 4 times 2, right? If I have $2, but I owe you 6, and I say, here's the 2, leave me alone, you're going to say, no, you still owe me 4, right? That's why it's a negative 4. Okay, now we have exponents. Negative 4 squared, y'all. Remember what that means? That means negative 4 times another negative 4. But we know a negative times a negative is that's 16. Divided by 4 times 2. Okay. Now, I'm going to go in order from left to right. What do you see first? Division. We got to do the division because step number 3 says you got to do whichever one comes first as we go from left to right. What's 16 divided by 4? 4. 4 times 2 is? 4 times 2 is 8, right? Okay. Is that one of my choices? There it is. Right? There it is. Okay. Now, guys, the one thing I always tell my students is, I think a lot of people tend to do this, is when you have a question that's multiple choice, we tend to look at our answer and say, okay, which is the right one? I don't want you to worry about that. Just run through the problem, and then at the end, your answer will be there, right? Instead of me worrying about, hold on, is it negative 4? Oh, is it 32? Oh, is it 8? Oh, let's just run through the problem. And likely our answer is going to be one of the choices, all right? Instead of getting sidetracked with looking at those 4 choices, just run through the problem and then see what we come up with, okay? Look, let's do the same thing here. Here's my second problem, y'all. Question, do I have any parentheses here? No, no parentheses. Okay, do we have any exponents? Okay, let's do that. So look, we're going to write 9 plus 64 divided by 64 times, what did we say 4 squared was again? 16. Okay, so we didn't have parentheses, so we didn't have to worry about it. We had exponents, so we did them. We're going to go left to right. I'm only looking at multiplying and dividing right now. What do you see first? Dividing. Okay, question. What's 64 divided by another 64? 1 times 16. Okay. I'm still looking at multiplying and dividing. Do we have any multiplying or dividing? What's 1 times 16? Okay. What's 9 plus 16? 25. Is that one of my choices? There we go. Guys, that's what I mean about don't get so bogged down with, hold on, is the answer 11? Or is it 584? You know what I mean? And I think a lot of times we tend to do that. We're like, oh, maybe it's 584. Why? I don't know. It's just a big number. That's got to be it, right? So I don't want you to worry too much about that kind of stuff. Okay. All right. Let's take a look at the next one we got here, y'all. I'm looking at this problem right here. Okay. So I see a set of parentheses right here, but those parentheses, guys, just have the number -7. There's no operation inside the -7, okay? So I want to make sure that we're clear with that. When we say operations within parentheses, meaning like we have 2 numbers, we're multiplying them, we're subtracting them, we're adding them, we're doing something inside. Here we just have the number -7. Do we have any exponents? No. Okay, we're going to look now multiplying, dividing as we go from left to right. As I go from left to right, doesn't that look like multiply? Okay, so we're going to go 95 minus, what's 5 times 11? 55, right? Good. Plus 42 divided by a -7. Okay, we still have some dividing here. Let's do that. 95 minus 55 plus, what's 42 divided, say, forget about the negative right now. What's 42 divided by 7? 6. But if it's a positive divided by a negative, it's going to be a -6. Okay, let's do the next part, y'all. We're going to go left to right. 95 minus 55, how much would that be? 40? But just this part right here, that'd be 40, right? Okay, plus -6. Guys, think about a positive is how much money you have, and a negative is how much money you owe. So if you had $40, but you owed your cousin $6, and your cousin says, hey man, I want my $6. Now you have how much? 34, and there's my answer. Okay. All right. So again, y'all, the way I take this approach is the more practice problems we do, I think the likelihood of us passing is going to be better. That's why I'm going through a bunch of problems with us today. Okay, let's take a look at the next one. Guys, I have parentheses. I want you to notice the difference in these parentheses and the one before. The one before was just -7 sitting by itself. Here I have 2 numbers and something is happening with them, right? So look, we're going to go 3 times 5 minus 3 times, what's 4 minus 2? 2. That's 2 being squared, right? Okay, we did our parentheses. Now we got exponents. Let's do our exponents. 2 squared means 2 times 2, which is 4. Okay. All right. Do we have any multiplying? Yeah, we do. What's 3 times 5? 15. Guys, remember, this means I'm multiplying, right? When I have a number right next to it in parentheses, it means we're multiplying. What's 3 times 4? 12, right? If I have $15 and I owe you 12, we're left with $3. Look, there's our answer. Now, y'all, when it comes to the test, one of the questions people ask me is, can I use the calculator? When you do the test, on certain problems, the calculator will pop up and it'll let you use it. And on other problems, a calculator is not going to pop up, so there's no calculator for you to do the problem, right? Is that the experience you had?
Well, the whole test there's calculator.
It was a calculator the whole
Yeah,
time?
the only difference is how,
What kind of calculator it is?
yeah, the simple.
Like a very basic calculator, right?
It's a basic calculator, but if you have
Like this?
like a square root or whatever, if you bring some more advanced.
Okay, so yeah, look guys, it says, she's saying, sometimes you get a basic calculator like this, other times you might get something a little more advanced, right? Okay, so look, let's do it like this. Let's use a basic calculator. No parentheses, right? No exponents. Do we have any multiplying or dividing? Okay, so we're going to take 240 and we're going to divide it by how much? 8. And we get 30. 30 minus 2. And there you go. Right? Okay. Let me keep scrolling down here, y'all. Again, we're going to try to go through as many problems as we can. All right. Again, no parentheses. I don't have any. I don't have any exponents, but I do have some multiplying. Okay, I already know what 5 times 3 is, right? That's what? 15. Okay. Guys, I am going to use my calculator because honestly, off the top of my head, what's 18 times 6? Pues quién sabe. 108. There we go. And if we were to add those numbers together, would we get? And there it is, right? Okay. So, y'all, for number 7, what would be the first thing that we would do? The division. Okay, so before I do that division problem, I'm going to ask you a question. Does anybody know what is 24 divided by 3? How many times does 3 go into 24? Nice and neat. 8. Okay, now, if I were to ask you why, would you say that 3 times 8 gives you 24? Okay, let me ask you another question. What is 35 divided by, say, 7? 5. Okay, and if I said the same thing, why? Would you say 7 times 5 is? Okay, so look, y'all, if we were to say, what's 48 divided by 0? What answer would you think? Okay, well, if we put 0, would you say 0 times 0 is going to give you 48? Okay, I was just kidding. It's not 0. What number do you think I could put there? Could I put 2? Would that work? Okay, no, I'm just kidding again. Do you guys see that no matter what number I put in that box, I'm never going to get what? Okay. That's why it's undefined. We can never divide by 0 because 0 times something will always give me 0, but it'll never give me that number 48. Does that make sense? Yeah. Okay. All right. Yo, when it comes to these types of problems where we have these fractions here, we're going to do the top piece. Yeah, we're going to think of the top piece, y'all. Think of the top piece as everything here is inside parentheses. Okay. Okay, so if I look at the top part, what should I do first? Should I do 16 plus 8 or should I do 8 divided by 2? Okay. What is 8 divided by 2? 4. Okay. 2 squared. Let's keep doing the top. What's 16 plus 4? 20? Okay. Can we do the bottom part? What's 2 squared? 4. Anybody know what 20 divided by 4 is? 5, right? Guys, remember we said a little while ago, why? Wouldn't we say 4 times 5 is 20, right? So is 5 my answer? There it is, right? Okay. I'm going to do the same thing, y'all, when it comes to this problem here. I'm going to put this guy in parentheses, top and the bottom. Let's do the top part first. What is 53 plus 7? 60. Okay. Now, let's work with the bottom. Can we do 3 squared? 9 minus 4. Okay. What is 9 minus 4 anyway? 5. Anybody know how many times 5 goes into 60? 12 times. And there's my choice, right? Guys, does it make sense on what I said about don't worry about your answer choices, just do the problem and it'll be there? Okay, good. Again, I just want to make sure that when you're taking your test, don't get too nervous about it. There are times when if you don't know what to do, then you're going to check your answer choices. We'll talk about that when we get there. Okay. Okay. So look, let's take a look. We got a few more to go through in regards to order of operation. Let's take care of the top part. So y'all, upstairs, what should we be doing first? Okay, 38. What is 16 minus 13? 3. Minus 6. I'm going to leave the bottom part alone for right now. Okay, remember y'all, this means I'm multiplying. So I'm going to take my calculator. What's 38 times 3? 114 minus 6. Anybody know what 114 minus 6 is? 108. Thank you so much. Okay, let's do the bottom part. Y'all, anybody know what is 3 squared? 9. What's 9 minus 3? 6. Last thing we're going to do, divide. 108 divided by 6, 18. And boom, there it is. Okay, so look, y'all, when I look at number 11 says insert parentheses so that the given expression evaluates to the given number. Okay, so we want to get negative 21. Okay, so, or 21, I'm sorry. So this is what we're going to do. This is a time when I would say, okay, well, what do I want to do first? Well, if I look at this part right here, what am I doing with each of those numbers? Okay, so look, y'all, if I were to say, what's 3 times 9? That's already going to give me what? Okay, I'm not going to get a 21 out of there, right? Because now I'm going to have to multiply that by a negative 2, negative 54. Okay, well, that's not my choice, right? Is there any difference in choice A and in choice B? No, it's still being multiplied, right? 3 times 9 times negative 2. Okay, well, if it wasn't my answer in choice A, I know it's not going to be my answer in choice B. Okay, let's look at this one. This one says we would have to do what first? Multiply. What's 3 times 9? 27. What's 27 minus 2? 25. But that's not what I want to get. I want to get 21. So that's not my choice. What does my choice have to be then? Has to be D. Let's make sure that it is. Okay, I'm going to check it off, but let's make sure that it is. Would you guys agree the first thing we'd have to do is 9 minus 2? What's 9 minus 2? And isn't 3 times 7 21? Does that make sense? So again, this one, because it said, look, put the parentheses, and it gave me the choices. Okay, now I'm going to go through my choices, right? Because I got to know which is the right one. Okay. All right. Okay, look, y'all, that's one topic done. Let's go to the next part, which is ratios and proportions. Okay. So ratio and proportions, y'all, say the ratio of a number A to B is their quotient. Ways of writing ratios are A to B or A with a colon B, or the one that we're going to use, y'all, because this is obviously a math thing, is the fraction, A over B. Okay, it just says write each ratio in fraction form reduced to lowest terms. The ratio of 15 miles to 40 miles. Y'all, all I'm doing here, 15 over 40, I'm going to write the word miles on both of them, okay, because that's the units that I have. Now, y'all, when we reduce fractions, one thing we're going to do is if the units are the same, I can reduce those two. So I can go ahead and get rid of them. Okay, 15 over 40. Is there a number common to both 15 and 40? 5, right? Okay, look, y'all, I'm going to do this real quick. Let me scroll back up here at the very top. I'm going to pull out my multiplication table because what I want to do here, y'all, is I'm going to look at my 5s. Whether I look at my 5s going left to right or look at my 5s going up and down. Here's 15, here's 40. That means they can both be divided by 5, right? So look, we're going to divide them both by 5. 5 goes into 15, 3 times. 5 goes into 40. If you need to look at the chart, you can. 5 goes into 40, how many times? 8. Oops, sorry. 8 times, and then we're done. Okay. The chart, y'all, in my opinion, comes in real helpful. Now, are you going to have the chart on the test? You're not. But the more that you use it, the more that you're going to remember those numbers. Okay. Okay. Now we have what we call rates. Rates, y'all, just mean that the units are different. Look what it says here: 5 shrubs for every 15 feet. 5 shrubs, 15 feet. Now I can't cancel the units because the units are different, but we can reduce the numbers. 5 shrubs for every 15 feet. Doesn't that mean that's the same thing as 1 shrub for every 3 feet? Right? Divided by 5? Okay. Look, 14 lab tables for 28 students. 14 tables, 28 students. Doesn't that mean that's the same thing as 1 table for every what? 2 students? That's all we're doing there. Okay. All right, let me keep moving along here. All right, so the next portion here, y'all, says a proportion is when 2 fractions are equal to each other. When 2 fractions are equal to each other, y'all, the way we do that is, the way we check is we cross multiply. So we say, look, what's 6 times 2? 6 times 2 is 12. We cross multiply this way too. What's 12 times 1? That's also 12. Okay. So when we have one fraction equal to another, we can cross multiply and set those 2 numbers equal to each other. Okay. So look, y'all, this is what I'm going to do in these problems here. I'm going to cross multiply. I'm going to say, well, look, because I'm trying to find that number. I don't know what it is. I'm going to say, look, what's x times 42? I don't know. I'm going to call it a 42x. Okay. What's 7 times 30? 210. Perfect. Thank you all so much. Now, if I want to find that number, y'all, the way I'm going to get rid of my 42, since it's being multiplied, I'm going to do the opposite, which is to divide. I'm going to divide everything here by 42. Okay. So I'm going to take 210 and I'm going to divide it by 42, and we should be coming up with 5, and there's my answer. Okay. And this is how I'm going to do every one of these problems. I have one fraction equals another one. I'm always going to cross multiply, set them equal to each other. The number in front of the x is the number I'm going to divide by, or y, or whatever letter they give me, okay? The letter is not really important. It could be a P, it could be a Q, doesn't make any difference. All right, look, let's do the same thing here. 32x. Whatever 8 times 28 is, 224. Now we divide by the number in front of the x. Anybody know what 224 divided by 32 is? 7. Look, there's my answer. Okay. And we're done. Okay, y'all, even when you come up with problems like this, I don't want you to get nervous, right? It's decimals, okay, it's decimals. I'm going to cross multiply. 1.6 with a y. Whatever that's going to give me. 2.3 times 6.9 is 15.87. What number should I divide by? Always a number in front of the letter. Very good. 1.6. Excellent, y'all. Good. Okay, so let's divide that out. Divided by 1.6. Okay, look what I'm coming up with. 9.91875. Okay, so I'm going to write that down. Now it tells me to round to the nearest tenth. Okay. The first number, y'all, is the tens position. Yeah, so we got to look at the number to the right of it, which is a 1. If that one would have been a 5, a 6, a 7, an 8, or a 9, then we'd have to bump it up. But because it's 4 or less, we leave it alone. What's my choice going to be? D, right? 9.9. Guys, it's just coincidence that a lot of the answers end up being D. Okay, so I don't want you to say, oh man, the answer is always going to be D. Right? I'm going to take my test D, 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 D all the way. Okay, doesn't work that way. All right. Okay, y'all, the reason why we did those kind of problems right now is these are the problems that we typically see when we do ratio and proportion type stuff. Okay, look what it says here. A recent advertisement claimed that 2 out of every 5 doctors recommend a certain herbal supplement to increase energy levels. If a local hospital employs 120 doctors, how many doctors would you expect to recommend the supplement? And it says round to the nearest whole number if necessary. Okay, first thing I look at is 2 out of every 5. So 2 out of every 5. So these are the doctors, right? And out of those 5 doctors, 2 of them are the ones that recommend whatever it is that telling you to take. Now, what's the total number of doctors we have? 120. Look, y'all, if I got doctors on the bottom, I'm going to put doctors on the bottom over here too. Does that make sense? And I'm going to put an X up here, and these are going to be the ones that recommend. Oops. I'm just going to put an R for recommend. Okay. And I'm going to cross multiply. So look, I'm going to say 5 times X, whatever that is. 2 times 20, I know that's 240. So I'll divide both sides by 5. And whatever that is. 240 divided by 5, 48. So 48 doctors are going to be the ones that recommend this. And look, there's my answer. And it was in D. Okay. Okay. Let's take a look at the next one. It says to estimate the number of people in Springfield, population 10,000, who have a swimming pool in their backyard. Okay, so guys, that first sentence is already a little confusing to me, right? Do we know the population of Springfield? It's 10,000. Look what it says. To estimate the number of people in Springfield, population 10,000, who have a swimming pool in their backyard. So what are they trying to find? How many people have a what? How many people who have a pool? We know how many people live in Springfield. We don't know how many have a pool. So we know the total population is 10,000. Okay, it says 250 people were interviewed. And out of those 250, 103 of them had a pool. How many people in the city might one expect to have a pool? Okay, so look, we're going to do this hopefully in a way that makes sense. How many people did we interview? 250. Out of those 250 people, how many of them had a pool? 103. Okay, so look, this is going to be people. That's going to be pool. Okay, do we know how many people live in Springfield? 10,000. That's 10,000 people. We don't know how many of them have a pool. Okay. So let's do this. 250x equals, well, whatever number that is, 103 times 10,000, 1,030,000. And we're now going to divide everything by 250. And I'm sorry, how much was it? 4120? Thank you so much. 4120. Was that one of our choices? There it is. There it is. It's A. Okay. All right. So y'all, the next one I have here says the ratio of, hello, I have a packet for you. You're welcome. Okay, look what it says, y'all. The ratio of a quarterback's completed passes to attempted passes is 8 to 9. Okay, so look, the first number is completed. The second number is attempted, right? So look, 8 completed out of 9 that they attempted, right? Look what it says here. If he attempted how many? 27. Where should I put the 27? On the bottom, right? Because those are attempted. We want to know how many did he complete, right? And it says round to the nearest whole number. Okay. Yes, of course. So look what it says. Let's come back right here. The ratio of completed to attempted is 8 to 9. So the first number is completed and the second number is attempted. So he completed 8 passes when he threw 9, right? So I'm going to throw the ball 9 times. 8 of them, the other guy's going to catch them. Now the next part says if he attempted 27, so he threw the ball 27 times, how many times would the people catch? All right. Yeah, that's what we're going to find, the number of completed, right? So look, we're going to multiply 9x, whatever, hello. 8 times 27 is, come on in, 216. Let's divide everything by 9. Very good, 24, right? Boom. Okay, you want to come in? Come on in. Guys, I'm going to stop recording for a second because Mr. Sanchez is here. He's going to talk